So the question is between methane, dihydrogen sulfide, and NH3, which one will have the highest boiling points? And so you want to draw the Lewis structures. It's all covalent, so they can be drawn out. And then you want to look at which intermolecular force is affecting which. And as you can see, it goes methane to dihydrogen sulfide to NH3. And that's because methane only has dispersion, and then as you go up more, the dihydrogen sulfide has dipole, and of course the NH3 has hydrogen bonds, which means it has the strongest level of intermolecular force, and that's why it will boil. It will take a higher rate of boiling. Let me rephrase. It will be a higher boiling point. So you want to draw out the Lewis structures and look at the IMFs affecting each compound, and that will tell you which one is a higher boiling point. So the next problem is about magnesium oxide and where it will fit in this structure of like which high, medium, low boiling point it will have. So it's ionic, which means that A, you can't draw a Lewis structure, and B, it will have a higher boiling point due to the ionic bond. So magnesium oxide is going to fall in the high boiling point, right next to NH3, and yeah. So the next question is where about water? Where will that go to? So if we draw it out, we know that it has dispersion, obviously. It definitely has a polar end of the molecule, or two polar ends, rather. And the hydrogen is bonded to an oxygen, which means it is a hydrogen bond. It's mislabeled in the diagram you're seeing right now, but water will be in the group of boiling points of NH3 and magnesium oxide due to its IMFs. And just a quick recap, whenever you have a problem like this of boiling points, you want to draw out the Lewis structure because it will tell you for covalent molecules, obviously ionic molecules have their own rules. Covalent, it will tell you which forces of intermolecular forces are being exhibited upon them. And from that, you can deduce that the lesser attracted or less IMFs per molecule, that it will have a lower boiling point, and vice versa. The higher the amount of IMFs, the higher the boiling point. So just a general rule of thumb is to draw the Lewis structures and pay attention to whether your compound is ionic or covalent.